Item 441. Steel structures. 1. Description. Fabricate and erect structural steel and other metals used for steel structures or for steel portions of structures. 2. Materials. 2.1 Base metal. Use metal that meets item 442, metal for structures. 2.2 Approved electrodes and flux electrode combinations. Use only electrodes and flux electrode combinations found on the department's MPL. To request a product be added to this list or to renew an expired approval, electronically submit a current certificate of conformance containing all tests required by the applicable AWSA 5 specification according to the applicable welding code. For most construction, TxDOT/AWSD 1.5, Bridge Welding Code, or AWSD 1.1, Structural Welding Code Steel, to the Construction Division. 2.3 High-strength bolts. Use fasteners that meet item 447, structural bolting. Use galvanized fasteners on field connections of bridge members when ASTM A325 bolts are specified and steel is painted. 2.4 Paint systems. Provide the paint system, surface preparation, primer, intermediate, and appearance coats as required, shown on the plans. Provide System 1V if no System 1 specified. 2.4.1 Standard paint systems. Standard paint systems for painting new steel include the following. 2.4.1.1 System 1-2B Provide paint in accordance with DMS 8101, Structural Steel Paints Performance. Provide inorganic zinc, IOZ, prime coat, epoxy intermediate coat, and urethane appearance coat for all outer surfaces except those to be in contact with concrete. Provide epoxy zinc prime coat for touch-up of IOZ. 2.4.1.2 System 1V. Provide paint in accordance with DMS 8101, Structural Steel Paints Performance. Provide IOZ prime coat and acrylic latex appearance coat for all outer surfaces except those to be in contact with concrete. Provide epoxy zinc prime coat for touch-up of IOZ. 2.4.2 Paint inside tub girders and closed boxes. Provide a white polyamide cured epoxy for all interior surfaces, including splice plate but excluding the faying surfaces, unless otherwise shown on the plans. Provide IOZ primer meeting the requirements of DMS 8101, Structural Steel Paints Performance, to all interior faying surfaces and splice plates. 2.4.3 Special Protection System. Provide the type of paint system shown on the plans or in special provisions to this item. Special protection systems must have completed NPEP structural steel coatings, SSC, testing regimen as a complete system, with full data available through NPEP. 2.4.4 Galvanizing. Provide galvanizing, as required, in accordance with item 445, galvanizing. 2.4.5 Paint over galvanizing. Paint over galvanized surfaces, when required, in accordance with item 445, galvanizing. 2.4.6 Field painting. Provide field paint, as required, in accordance with item 446, field cleaning and painting steel. 3. Construction. 3.1 General requirements. 3.1.1 Applicable codes. Perform all fabrication of bridge members in accordance with TxDOT/NSBA Steel Bridge Collaboration S2.1. Follow all applicable provisions of the appropriate AWS code, D1.5 or D1.1, except as otherwise noted on the plans or in this item. Weld sheet steel, thinner than 1/8 inches, in accordance with ANSI/AWSD 1.3, Structural Welding Code sheet steel. Unless otherwise stated, requirements of this item are in addition to the requirements of S2.1 for bridge members. Follow the more stringent requirement in case of a conflict between this item and S2.1. Perform all bolting in accordance with item 447, structural bolting. Fabricate railroad underpass structures in accordance with the latest ARIMA manual for railway engineering and this item. In the case of a conflict between this item and the ARIMA manual, the more stringent requirements apply. 3.1.2 Notice of Fabrication. Give adequate notice before commencing fabrication work as specified in Table 1. Include a schedule for all major fabrication processes and dates when inspections are to occur. Table 1. Notice of beginning work. Plant location and notice required. Plant location in Texas requires a notice of 7 days. Plant location in the contiguous United States requires a notice of 21 days. Plant location outside the contiguous United States requires a notice of 60 days. Perform no department work in the plant before the engineer authorizes fabrication. The contractor must bear all department travel costs when changes to their fabrication or inspection schedules are not adequately conveyed to the department. When any structural steel is fabricated outside of the contiguous 48 states, the additional cost of inspection will be in accordance with Article 6.4, Sampling, Testing, and Inspection. 3.1.3 Bridge members. Primary bridge members include web and flanges of plate, tub, and box girders, rolled beams and cover plates, floor beam webs and flanges, arch ribs and arch tie beams or girders, truss members, diaphragm members for curved plate girders or beams, pier diaphragm members for tub girders, splice plates for primary members, and any other member designated as primary or main on the plans. Secondary bridge members include bracing, diaphragms, cross frames, and lateral bracing, and all other miscellaneous bridge items not considered primary bridge members. 3.1.4 Responsibility. The contractor is responsible for the correctness and completeness of shop drawings and for the fit of shop and field connections. 3.1.5 Qualification of plants and personnel. 3.1.5.1 Plants. Fabrication plants that produce bridge members must be approved in accordance with DMS 7370, Steel Bridge Member Fabrication Plant Qualification. The department's MPL has a list of approved bridge member fabrication plants. Fabrication plants that produce non-bridge steel members listed below must be approved in accordance with DMS 7380, Steel Non-Bridge Member Fabrication Plant Qualification. The Construction Division maintains a list of approved non-bridge fabrication plants for the following items: roadway illumination poles, high mast illumination poles, high mast rings and support assemblies, overhead sign support structures, traffic signal poles, and Intelligent Transportation System, ITS, poles. The department will evaluate non-bridge member fabrication plants for competence of the plant, equipment, organization, experience, knowledge, and personnel to produce acceptable work. 3.1.5.2 Personnel. Provide a QC staff qualified in accordance with the applicable AWS code. Provide an adequate number of qualified QC personnel for each specific production operation. QC must be on-site and independent of production personnel, as the engineer determines. QC personnel must be proficient in utilizing the applicable plans, specifications, and test methods, and in verifying compliance with the plant QC and production procedures. Welding inspectors must be current AWS certified welding inspectors for bridge member plants, and for non-bridge member plants requiring department approval per DMS 7380, Steel Non-Bridge Member Fabrication Plant Qualification. The QC staff must provide inspection of all materials and workmanship before the department's inspection. Provide the department inspector with adequate personnel and equipment needed to move material for inspection access. QC is solely the contractor's responsibility. 3.1.5.3 Non-Destructive Testing, NDT. Personnel performing NDT must be qualified in accordance with the applicable AWS code and the employer's written practice. Level 3 personnel who qualify as Level I and Level 2 inspectors must be certified by ASNT, for which the NDT Level 3 is qualified. Testing agencies and individual third-party contractors must also successfully complete periodic audits for compliance, performed by the department. In addition, ultrasound technicians must pass a hands-on test the construction division administers. This will remain current provided they continue to perform testing on department materials as evidenced by test reports requiring their signature. A technician who fails the hands-on test must wait 6 months before taking the test again. Qualification to perform ultrasonic testing will be revoked when the technician's employment is terminated or when the technician goes 6 months without performing a test on a department project. The technician must pass a new hands-on test to be recertified. 3.1.5.4 Welding Procedure Specifications Qualification Testing. For bridge member fabrication, laboratories performing welding procedure specifications, WPSs, qualified by testing must be approved in accordance with DMS 7360, Qualification Procedure for Laboratories Performing Welding Procedure Qualification Testing. The department's MPL has a list of laboratories approved to perform WPS qualification testing. 3.1.6 Drawings. 3.1.6.1 Erection Drawings. Submit erection drawings prepared by a licensed professional engineer, including calculations, for approval in accordance with Item 5, Control of the work, at least 4 weeks before erecting any portion of field spliced, welded or bolted, girders, railroad underpasses, trusses, arches, or other members for which erection drawings are required on the plans. Include drawings and calculations for any temporary structures used to support partially erected members. Erection drawings are not required for rolled I-beam units unless otherwise noted on the plans. Prepare erection drawings following the procedures outlined in Section 2.2 of the OSHTO/NSBA Steel Bridge Collaboration S10.1. As a minimum, include plan of work area showing structure location relative to supports and all obstructions. Equipment to be used including allowable load information. Erection sequence for all pieces. Member weights and center of gravity location of pieces to be lifted. Locations of cranes, holding cranes, and temporary supports, false work, including when to release load from temporary supports and holding cranes. Details of false work including specific bracing requirements with maximum allowable design wind speed clearly indicated. Girder lifting points. Diaphragm and bracing requirements, and minimum connection requirements when more than the standard requirements. Perform girder erection analyses using UT Lift and UT Bridge software available on the department's website or other suitable commercial software. Ensure temporary stresses in members being erected will not cause permanent damage and that stability is maintained throughout the erection operations. Provide actual input files and output results from UT Lift and UT Bridge, or graphical and hard copy results from commercial software programs. Do not proceed if site conditions differing from those depicted on the approved erection drawings could affect temporary support stresses, erected girders, or public safety in any manner. Revise erection drawings and resubmit to the engineer for approval before proceeding if site conditions could affect these things. 3.1.6.2 Shop Drawings. Prepare and electronically submit shop drawings before fabrication for each detail of the general plans requiring the use of structural steel, forgings, wrought iron, or castings as documented in the Guide to Electronic Shop Drawing submittal available on the Bridge Division website and as directed for other items the standard specifications require. Indicate joint details on shop drawings for all welds. Provide a title block on each sheet in the lower right corner that includes project identification data including federal and state project numbers. Sheet numbering for the shop drawings. Name of the structure or stream for bridge structures. Name of owner or developer. Name of the fabricator or supplier, and name of the contractor. Provide one set of 11 x 17 inches approved shop drawings in hard copy to the department for the inspector at the fabrication plant. 3.1.6.2.1 Bridge members. Prepare drawings in accordance with TxDOT/NSBA Steel Bridge Collaboration G1.3, shop detail drawing presentation unless otherwise approved. Print a bill of material on each sheet, including the Sharpie V notch, CVN, and fracture critical requirements, if any, for each piece. Indicate fracture critical areas of members. 3.1.6.2.2 Non-bridge members. Furnish shop drawings for non-bridge members when required by the plans or pertinent items. 3.1.7 Welding Procedure Specifications, WPSs. Submit WPSs and test reports in accordance with the applicable AWS code to the construction division before fabrication begins, and notify the engineer which procedures will be used for each joint or joint type. Do not begin fabrication until the engineer approves WPSs. Post the approved WPSs for the welding being performed on each welding machine, or use another approved method of ensuring the welder has access to the procedure information at all times. 3.1.8 Documentation. Before beginning fabrication, provide a completed material statement Form 1818, aka D9 USA 1, with supporting documentation, such as mill test reports, MTRs, that the producing mill issues and qualified personnel verifies. Ensure the documentation legibly reflects all information the applicable ASTM specifications require. Supply documents electronically to the department. Provide a copy of the shipping or storage invoice, as material is shipped or placed in approved storage that reflects member piece mark identification and calculated weight per piece from the contract drawings. Number of pieces shipped or in storage. Total calculated weight for each invoice per bid item, and the unique identification number of the shipping or storage invoice. The inspector's acceptance of material or finished members will not prohibit subsequent rejection if the material or members are found to be damaged or defective. Replace rejected material promptly. 3.1.9 Material Identification. Assembly mark individual pieces and issue cutting instructions to the shop using a system that will maintain identity of the original piece. Identify structural steel by standard and grade of steel. Also differentiate between material toughness requirements, CVN, fracture critical, as well as any other special physical requirements. In addition, identify structural steel for primary members by mill identification numbers, heat numbers. Use an approved identification system. Use either paint or low-stress stencils to make identification markings on the metal. Mark the material as soon as it enters the shop and carry the markings on all pieces through final fabrication. Transfer the markings before cutting steel for primary members of bridge structures into smaller pieces. Loss of identification marking on any piece, with no other positive identification, or loss of heat number identification on any primary member piece will render the piece unacceptable for use. Unidentifiable material may be approved for use after testing to establish acceptability to the satisfaction of the engineer. Have an approved testing facility perform testing and a licensed professional engineer sign and seal the results. 3.2 Welding. 3.2.1 Details. 3.2.1.1 Rolled edges. Trim plates with rolled edges used for webs by thermal cutting. 3.2.1.2 Weld tabs. Use weld tabs at least 2 inches long for manual and semi-automatic processes, at least 3 inches long for automatic processes, and in all cases at least as long as the thickness of the material being welded. Use longer weld tabs as required for satisfactory work. 3.2.1.3 Weld termination. Terminate fillet welds approximately 1/4 inches from the end of the attachment except for galvanized structures and flange to web welds, for which the fillet weld must run the full length of the attachment, unless otherwise shown on the plans. 3.2.1.4 No paint areas at field welded connections. Keep surfaces within 4 inches of groove welds or within 2 inches of fillet welds free from shop paint. 3.2.1.5 Galvanized assemblies. Completely seal all edges of tightly contacting surfaces by welding before galvanizing. 3.2.1.6 Submerged arc welding, SAW. Do not use handheld semi-automatic SAW for welding bridge members unless altered to provide automatic guidance or otherwise approved. 3.2.1.7 Tubular stiffeners for bridge members. Weld in accordance with AWSD 1.5, using WPSs qualified based on tests on ASTM A709 GR50W or GR50 steel for non-weathering applications and ASTM A709 GR50W steel for weathering applications. 3.2.1.8 Non-bridge member weathering steel welds. Provide weld metal with atmospheric corrosion resistance and coloring characteristics similar to that of the base metal for weathering steel structures fabricated per AWSD 1.1. 3.2.2 Shop splices. 3.2.2.1 Shop splice locations. Keep at least 6 inches between shop splices and stiffeners or cross frames. Obtain approval for shop splices added after shop drawings are approved. 3.2.2.2 Grinding splice welds. Grind shop groove welds in flange plates smooth and flush with the base metal on all surfaces whether the joined parts are of equal or unequal thickness. Grind so the finished grinding marks run in the direction of stress, and keep the metal below the blue brittle range, below 350 degrees Fahrenheit. Groove welds in web plates, except at locations of intersecting welds, need not be ground unless shown on the plans except as required to meet AWS welding code requirements. 3.2.3 Joint restraint. Never restrain a joint on both sides when welding. 3.2.4 Stiffener installation. 3.2.4.1 Flange tilt. Members must meet combined tilt and warpage tolerances before the installation of stiffeners. Cut stiffeners to fit acceptable flange tilt and cupping. Minor jacking or hammering that does not permanently deform the material will be permitted. 3.2.4.2 Stiffeners near field splices. Tack weld intermediate stiffeners within 12 inches of a welded field splice point in the shop. Weld the stiffeners in the field in accordance with item 448, structural field welding, after the splice is made. 3.2.5 Non-destructive testing, NDT. Perform magnetic particle testing, MT, radiographic testing, RT, or ultrasonic testing, UT, at the contractor's expense as specified in D1.5 for bridge structures. The engineer will periodically witness, examine, verify, and interpret NDT. Additional welds may be designated for NDT on the plans. Retest repaired groove welds per the applicable AWS code after repairs are made and have cooled to ambient temperature. Complete NDT and repairs before assembly of parts into a member, but after any heat correction of weld distortion. 3.2.5.1 Radiographic testing. Radiographs must have a density of at least 2.5 and no more than 3.5, as a radiographer confirms. The density in any single radiograph showing a continuous area of constant thickness must not vary in this area by more than 0.5. Use only ASTM System Class 1 radiographic film as described in ASTM E1815. Use low-stress stencils to make radiograph location identification marks on the steel. 3.2.5.2 Ultrasonic testing. Have UT equipment calibrated yearly by an authorized representative of the equipment manufacturer or by an approved testing laboratory. 3.2.5.3 Magnetic particle testing. Use half-wave rectified DC when using the yoke method unless otherwise approved. Welds may be further evaluated with prod method for detecting center line cracking. 3.2.6 Testing of galvanized weldments. If problems develop during galvanizing of welded material, the engineer may require a test of the compatibility of the combined galvanizing and welding procedures in accordance with this section and may require modification of one or both of the galvanizing and welding procedures. Prepare a test specimen with a minimum length of 12 inches using the same base material, with the same joint configuration, and using the welding procedure proposed for production work if testing is required. Clean and galvanize this test specimen using the same conditions and procedure that will be applied to the production galvanizing. Examine the test specimen after galvanizing. There must be no evidence of excessive buildup of zinc coating over the weld area. Excessive zinc coating buildup will require modification of the galvanizing procedure. Remove the zinc from the weld area of the test specimen and visually examine the surface. There must be no evidence of loss of weld metal or any deterioration of the base metal due to the galvanizing or welding procedure. Modify the galvanizing or welding procedure as required if there is evidence of deterioration or loss of weld metal, and run a satisfactory retest on the modified procedures before production work. Report procedures and results on the galvanized weldment worksheet provided by the department. 3.3 Bolt holes. Detail holes on shop drawings 1/16 inches larger in diameter than the nominal bolt size shown on the plans unless another hole size is shown on the plans. Thoroughly clean the contact surfaces of connection parts in accordance with item 447, structural bolting, before assembling them for hole fabrication. Make holes in primary members full size, by reaming from a subsize hole, drilling full size, or punching full size where permissible, only in assembly unless otherwise approved. Ream and drill with twist drills guided by mechanical means unless otherwise approved. If sub-punching holes, punch them at least 3/16 inches smaller than the nominal bolt size. Submit the proposed procedures for approval to accomplish the work from initial drilling or punching through check assembly when numerically controlled, N/C, equipment is used. Use thermal cutting for holes only with permission of the engineer. Permission for thermal cutting is not required for making slotted holes, when slotted holes are shown on the plans, by drilling or punching 2 holes and then thermally cutting the straight portion between them. Perform all thermal cutting in accordance with section 441.3.5.1, thermal cutting. Slightly conical holes that naturally result from punching operations are acceptable provided they do not exceed the tolerances of S2.1. The tolerance for anchor bolt hole diameter for bridge bearing assemblies is plus 1/8 inches, 0. 3.4 Dimensional tolerances. Meet tolerances of the applicable AWS specifications and S2.1 except as modified in this section. 3.4.1 Rolled sections. Use ASTM A6 mil tolerances for rolled sections, except D1.5 camber tolerances apply to rolled sections with a specified camber. 3.4.2 Flange straightness. Ensure flanges of completed girders are free of kinks, short bends, and waviness that depart from straightness or the specified camber by more than 1/8 inches in any 10 feet along the flange. Rolled material must meet this straightness requirement before being laid out or worked. Plates must meet this requirement before assembly into a member. Inspect the surface of the metal for evidence of fracture after straightening a bend or buckle. The engineer may require non-destructive testing. 3.4.3 Alignment of deep webs in welded field connections. For girders 48 inches deep or deeper, the webs may be slightly restrained while checking compliance with tolerances of S2.1 for lateral alignment at field welded connections. In the unrestrained condition, webs 48 inches deep or deeper must meet the tolerances of Table 2. Girders under 48 inches deep must meet the alignment tolerances of S2.1. Table 2. Web alignment tolerances for deep girders. Web depth, inches, and maximum web misalignment, inches. Beam with a web depth of 48 inches has a maximum allowable web misalignment of 1/16 inches. Beam with a web depth of 60 inches has a maximum allowable web misalignment of 1/8 inches. Beam with a web depth of 72 inches has a maximum allowable web misalignment of 1/4 inches. Beam with a web depth of 84 inches has a maximum allowable web misalignment of 5/16 inches. Beam with a web depth of 96 inches has a maximum allowable web misalignment of 5/16 inches. Beam with a web depth of 108 inches has a maximum allowable web misalignment of 3/8 inches. Beam with a web depth of 120 inches has a maximum allowable web misalignment of 7/16 inches. Beam with a web depth of 132 inches has a maximum allowable web misalignment of 7/16 inches. Beam with a web depth of 144 inches has a maximum allowable web misalignment of 1/2 inches. 3.4.4 Bearings. Correct bearing areas of shoes, beams, and girders using heat, external pressure, or both. Grind or mill only if the actual thickness of the member is not reduced by more than 1/16 inches below the required thickness. 3.4.4.1 I-beams, plate girders, and tub girders. The plane of the bearing area of beams and girders must be perpendicular to the vertical axis of the member within 1/16 inches in any 24 inches. 3.4.4.2 Closed box girders. Meet these tolerances. The plane of the bearing areas of the box girder is perpendicular to the vertical axis of the girder within 1/16 inches across any horizontal dimension of the bearing. The planes of the beam supports on the box girder are true to the vertical axis of the supported beams or girders to 1/16 inches in any 24 inches. In the shop, verify the plane of all bearing areas with the box placed on its bearings to field grade, using an approved process for verification. 3.4.4.3 Shoes. Meet these tolerances. The top bolster has the center 75% of the long dimension, transverse to the girder, true to 1/32 inches, with the remainder true to 1/16 inches, and is true to 1/32 inches across its entire width in the short dimension, longitudinal to the girder. The bottom bolster is true to 1/16 inches across its diagonals. For a pin and rocker type expansion shoe, the axis of rotation coincides with the central axis of the pin. When the shoe is completely assembled, as the top bolster travels through its full anticipated range, no point in the top bolster plane changes elevation by more than 1/16 inches and the top bolster does not change inclination by more than 1 degree, for the full possible travel. 3.4.4.4 Beam supports. Fabricate beam support planes true to the box girder bearing to 1/16 inches in the short direction and true to the vertical axis of the nesting girders to 1/16 inches. 3.4.5 End connection angles. For floor beams and girders with end connection angles, the tolerance for the length back-to-back of connection angles is plus or minus 1/32 inches. Do not reduce the finished thickness of the angles below that shown on the shop drawings if end connections are faced. 3.5 Other fabrication processes. 3.5.1 Thermal cutting. Use a mechanical guide to obtain a true profile. Hand cut only where approved. Hand cutting of radii for beam copes, weld access holes, and width transitions is permitted if acceptable profile and finish are produced by grinding. Provide a surface finish on thermal cut surfaces, including holes, in accordance with D1.5 requirements for base metal preparation. Obtain approval before using other cutting processes. 3.5.2 Oxygen gouging. Do not oxygen gouge quenched and tempered, Q&T, normalized, or thermomechanically controlled processed, TMCP, steel. 3.5.3 Annealing and normalizing. Complete all annealing or normalizing, as defined in ASTM A941, before finished machining, boring, and straightening. Maintain the temperature uniformly throughout the furnace during heating and cooling so the range of temperatures at all points on the member is no more than 100 degrees Fahrenheit. 3.5.4 Machining. Machine the surfaces of expansion bearings so the travel direction of the tool is in the direction of expansion. 3.5.5 Camber. Complete cambering in accordance with S2.1 before any heat curving. 3.5.6 Heat curving. Heat curve in accordance with S2.1. The methods in the Oshto bridge construction specifications are recommended. Attach cover plates to rolled beams before heat curving only if the total thickness of one flange and cover plate is less than 2.5 inches and the radius of curvature is greater than 1,000 feet. Attach cover plates for other rolled beams only after heat curving is completed. Locate and attach connection plates, diaphragm stiffeners, and bearing stiffeners after curving, unless girder shrinkage is accounted for. 3.5.7 Bending of quenched and tempered steels. The cold bending radius limitations for HPS 70W in S2.1 apply to all Q&T steels. 3.6 Nonconformance reports, NCRs. Submit an NCR to the engineer for approval when the requirements of this item are not met. Submit NCRs in accordance with the Construction Division's NCR Guidelines document. Have readily available access to the services of a licensed professional engineer experienced in steel structures design and fabrication. This licensed professional engineer may be responsible for reviewing potentially structurally deficient members in accordance with the NCR Guidelines document. Receive department approval before beginning repairs. Perform all repair work in strict compliance with the approved NCR and repair procedure. 3.7 Shop Assembly. 3.7.1 General Shop Assembly. Shop assemble field connections of primary members of trusses, arches, continuous beam spans, vents, towers, each face, plate girders, field connections of floor beams and stringers, including for railroad structures, field bolted diaphragms for curved plate girders and railroad underpasses, and rigid frames. Field bolted cross frames and rolled section diaphragms do not require shop assembly. Complete fabrication, welding, except for shear studs, and field splice preparation before members are removed from shop assembly. Obtain approval for any deviation from this procedure. The contractor is responsible for accurate geometry. Use a method and details of pre-assembly consistent with the erection procedure shown on the erection plans and camber diagrams. The sequence of assembly may start from any location in the structure and proceed in one or both directions. An approved method of sequential geometry control is required unless the full length of the structure is assembled. Verify by shop assembly the fit of all bolted and welded field connections between bent cap girders and plate girders or between plate girders and floor beams. Do not measure horizontal curvature and vertical camber for final acceptance until all welding and heating operations are completed and the steel has cooled to a uniform temperature. Check horizontal curvature and vertical camber in a no-load condition. 3.7.2 Bolted field connections. Each shop assembly, including camber, alignment, accuracy of holes, and fit of mill joints, must be approved before the assembly is dismantled. Assemble with milled ends of compression members in full bearing. Assemble non-bearing connections to the specified gap. Ream all subsize holes to the specified size while the connections are assembled, or drill full size while the connections are assembled. Notify the engineer before shipping if fill plates or shims are added. Adding or increasing the thickness of shims or fill plates in bearing connections requires approval. Use drift pins and snug tight bolts during the drilling process to ensure all planes of the connection, webs and flanges, can be assembled simultaneously. Do not use tack welds to secure plates while drilling. Secure parts not completely bolted in the shop with temporary bolts to prevent damage in shipment and handling. Never use tack welds in place of temporary bolts. Match mark connecting parts in field connections using low-stress stencils in accordance with the diagram in the erection drawings. 3.7.3 Welded field connections. Mill or grind bevels for groove welds. Do not cut into the web when cutting the flange bevel adjacent to the web. End preparation, backing, and tolerances for girder splices must be in accordance with item 448, structural field welding. Details for all other field welds must conform to the applicable AWS code unless otherwise shown on the plans. In the shop, prepare ends of beams or girders to be field welded taking into account their relative positions in the finished structure due to grade, camber, and curvature. Completely shop assemble and check each splice. Match mark the splice while it is assembled with low-stress stencils in accordance with the diagram in the erection drawings. 3.8 Finish and painting. 3.8.1 Shop painting. Perform shop painting of bridge members as required in DMS 8104, paint, shop application for steel bridge members. Grind corners on new steel items to be painted, except for the coatings on box and tub girder interiors, that are sharp or form essentially 90 degrees angles to an approximately 1/16 inches flat surface before blast cleaning. A corner is the intersection of two plane faces. This requirement does not apply to punched or drilled holes. Do not omit shop paint to preserve original markings. Ensure painted faying surfaces meet the required slip and creep coefficients for bolted connections as outlined in DMS 8104, Paint, Shop application for steel bridge members. Use a Class A slip, minimum slip coefficient of 0.33, if no slip coefficient or corresponding surface condition is specified, perform all required testing at no expense to the department. Surface preparation and painting the interiors of tub girders and closed boxes is in accordance with DMS 8104, Paint, Shop application for steel bridge members. 3.8.2 Weathering steel. Provide an SSPC SP6 blast in the shop to all fascia surfaces of unpainted weathering steel beams. Fascia surfaces include exterior sides of outermost webs and undersides of bottom flanges of plate girders and rolled beams. All outer surfaces of tub girders and box girders. All surfaces of truss members. Webs and undersides of bottom flanges of plate diaphragms. Bottom surfaces of floor beams, and any other surfaces designated as fascia on the plans. Do not mark fascia surfaces. Use one of the following methods as soon as possible to remove any markings or any other foreign material that adheres to the steel during fabrication and could inhibit the formation of oxide film. SSPC SP1, Solvent cleaning. SSPC SP2, Hand tool cleaning. SSPC SP3, Power tool cleaning, and SSPC SP7, Brush off blast cleaning. Do not use acids to remove stains or scales. Feather out touched up areas over several feet. 3.8.3 Machine surfaces. Clean and coat machine finished surfaces that are in sliding contact, particularly pins and pinholes, with a non-drying, water-repellent grease-type material containing rust-inhibitive compounds. Ensure the coating material contains no ingredients that might damage the steel. Protect machine surfaces from abrasive blasting. 3.9 Handling and storage of materials. Prevent damage when storing or handling girders or other materials. Remove or repair material damaged by handling devices or improper storage by acceptable means in accordance with ASTM A6 and the applicable AWS code. Place stored materials on skids or acceptable dunnage above the ground. Keep materials clean. Shore girders and beams to keep them upright and free of standing water. Place support skids close enough to prevent excessive deflection in long members such as columns. Do not stack completed girders or beams at the job site. Protect structural steel from salt water or other corrosive environments during storage and transit. 3.10 Marking and shipping. Mark all structural members in accordance with the erection drawings. If a surface is painted, make the marks over the paint. Do not use impact-applied stencils to mark painted surfaces. Mark the weight directly on all members weighing more than 3 tons. Keep material clean and free from injury during loading, transportation, unloading, and storage. Pack bolts of each length and diameter, and loose nuts or washers of each size, separately and ship them in boxes, crates, kegs, or barrels. Plainly mark a list and description of the contents on the outside of each package. 3.11 Field erection. Do not lift and place any steel member, including girders and diaphragms, over an open highway or other open travelway unless otherwise approved. Do not allow traffic to travel under erected members until sufficiently stable as shown on approved erection drawings. 3.11.1 Pre-erection conference. Schedule and attend a pre-erection conference with the engineer at least 7 days before commencing steel erection operations. Do not install false work or perform any erection operations before the meeting. 3.11.2 Methods and equipment. Do not tack weld parts instead of using erection bolts. Do not tack weld parts to hold them in place for bolting. Provide false work, tools, machinery, and appliances, including drift pins and erection bolts. Provide enough drift pins, 1/32 inches larger than the connection bolts, to fill at least 1/4 of the bolt holes for primary connections. Use erection bolts of the same diameter as the connection bolts. Securely tie, brace, or shore steel beams or girders immediately after erection as shown on the erection drawings. Maintain bracing or shoring until the diaphragms are in place and as specified in the erection drawings. Protect railroad, roadway, and marine traffic underneath previously erected girders or beams from falling objects associated with other construction activities. Only welders certified or working directly under the supervision of a foreman certified in accordance with Item 448, structural field welding, may handle torches when applying heat to permanent structural steel members. 3.11.3 False work. Construct false work in accordance with the erection plan. Construct foundations for shore towers as shown on erection drawings. Do not use timber mats with deteriorated timbers or soil to construct shore tower foundations. Notify the engineer of completed false work to obtain approval before opening roadway to traffic or starting girder erection activities. Ensure false work is protected from potential vehicle impact. Inspect and maintain false work daily. Use screw jacks or other approved methods to control vertical adjustment of false work to minimize the use of shims. 3.11.4 Handling and assembly. Accurately assemble all parts as shown on the plans and the approved shop drawings. Verify match marks. Handle parts carefully to prevent bending or other damage. Do not hammer if doing so damages or distorts members. Do not weld any member for transportation or erection unless noted on the plans or approved by the engineer. 3.11.4.1 Welded connections. Weld flange splices to 50% of their thickness and meet the minimum erection bracing and support requirements before releasing the erection cranes, as shown on the plans and on the approved erection plans. Field weld in accordance with Item 448, structural field welding. 3.11.4.2 Bolted connections. Before releasing the erection cranes, install 50% of the bolts in the top and bottom flanges and the web with all nuts finger tight. Meet the minimum erection bracing and support requirements shown on the plans and on the approved erection plans, and install top lateral bracing across the connection for tub girders, and fully tension the bolts connecting the bracing to the top flanges. Install high-strength bolts, including erection bolts, in accordance with Item 447, structural bolting. Clean bearing and faying surfaces for bolted connections in accordance with Item 447, structural bolting. Clean the areas of the outside ply under washers, nuts, and bolt heads before bolt installation. Ensure the required faying surface condition is present at the time of bolting. 3.11.5 Misfits. Correct minor misfits. Ream no more than 10% of the holes in a plate connection, flange or web, and ensure no single hole is more than 1/8 inches larger than the nominal bolt diameter. Submit proposed correction methods for members with defects that exceed these limits or prevent the proper assembly of parts. Straighten structural members in accordance with S2.1. Make all corrections in the presence of the engineer at no expense to the department. Do not remove and re-weld gusset plates without approval. 3.11.6 Bearing and anchorage devices. Place all bearing devices such as elastomeric pads, castings, bearing plates, or shoes on properly finished bearing areas with full and even bearing on the concrete. Place metallic bearing devices on January 4 inches thick preformed fabric pads manufactured in accordance with DMS 6160, water stops, nylon reinforced neoprene sheet, and elastomeric pads, to the dimensions shown on the plans. Provide holes in the pad that are no more than 1/4 inches larger than the bolt diameter. Build the concrete bearing area up to the correct elevation once it has been placed below grade using mortar that meets item 420, concrete substructures, and provide adequate curing. Use only mortar for build UPS between 1/8 inches and 3/8 inches thick. Use galvanized steel shims or other approved shim materials in conjunction with mortar if the bearing area must be raised more than 3/8 inches. Provide at least 75% contact of flange tissue with no separation greater than 1/32 inches for beams and girders. Make corrections using heat or pressure in accordance with S2.1, or with galvanized shims. Correct small irregularities by grinding. Provide at least 85% contact between the rocker plate and the base plate. Adjust the location of slotted holes in expansion bearings for the prevailing temperature. Adjust the nuts on the anchor bolts at the expansion ends of spans to permit free movement of the span. Provide lock nuts or burr the threads. Remove all foreign matter from sliding or machine finished surfaces before placing them in the structure. Restore distorted bearing pads or expansion bearings to an equivalent 70 degrees Fahrenheit position after completion of all welded or bolted splices, using an approved method of relieving the load on the bearing devices. 3.11.7 Erecting forms. Do not erect forms until all welding or bolting is complete and the unit is positioned and properly set on the bearings unless otherwise noted on the plans. 3.11.8 Field finish. Paint in accordance with item 446, field cleaning and painting steel. Restore weathering steel that will remain unpainted to a uniform appearance by solvent cleaning, hand cleaning, power brush, or blast cleaning after all welding and slab concrete placement has been completed. Remove from all unpainted weathering steel fascia surfaces, see section 441.3.8.2, weathering steel, any foreign material, including markings, that adheres to the steel and could inhibit formation of oxide film as soon as possible. Feather out touched up areas over several feet. Do not use acids to remove stains or scales. For measurement and payment. The work performed, materials furnished, equipment, labor, tools, and incidentals will not be measured or paid for directly but will be subsidiary to pertinent items.